All right, so we're gonna go through two sections today. Both these sections involve the same sort of thing, and the common theme to them both is we are going to be talking about what's called equivalent statements. Okay, the word equivalent, if you remember when we were talking about sets, equivalent sets had the same number of elements. Now, equivalent here means something a little bit different than it did in sets. So what we say is two statements are equivalent. So we're just going to fill in that word. Two statements are called equivalent, and in logic, the symbol that our book uses is an equal sign with 3 bars. I think that's the same symbol we use with sets. And two statements are equivalent if they have the exact same truth values in their answer column. So when you're looking at the answer column for whatever, it is the same sequence of T's and F's, not the same number of T's and F's, but in the exact same place as well. That's what it means to be equivalent. Now, under the same circumstances, it has the same truth value. Okay, so if you say things in words one way versus another way, and we're going to go through a whole bunch of examples of that. So here's your first exercise. This is a great exercise just to remind us of where we've been. Here are two statements. First statement is P and in parentheses Q or R. And I want to know, and you're going to show, is that equivalent to P and Q in parentheses or P and R in parentheses? Okay, so this is just a nice warm-up exercise. You're going to do the truth tables for both of those statements, and then you're going to compare the answer columns of both. So I'm going to give you a minute or two to do that. And go through your conjunctions and disjunctions. All right, so I'm going to do the statement on the left, the P and Q or R in parentheses. I'm going to do this one in orange. Okay, so I think you would tell me this, but again, this is just nice review. Where am I going to start doing the truth table for this statement right here? The parentheses. I'm going to do the Q or R. And I imagine if I asked the disjunction an or statement, when is an or statement true? When either one of them is true. Okay, so here we go. Q or R. So I'm going down the Q and the R column. True or true, that's going to be a true statement. True or false, true statement. False or true, true statement. False or false, that's a false statement. And again, through the whole sequence. True or true, that's a true statement. True or false, that's a true statement. False or true. and then false or false. So there we go. 3 T's and F, 3 T's and F. And then to finish this up, we just need one more column. I'm going to take the P and I'm going to AND it with the Q or R column. Okay, so the conjunction, again, I'm hoping that this is second nature to you by now. The conjunction, the AND statement, when is it true? When both are true. So here's the statement P, I'm going to put a little dot there. Here's the Q or R, I'm going to put a dot there. And so here we go. Both have to be true for the AND statement. So true and true, the first one's true right out of the gate. True or true, so is the second one. True and true, so is the third. True and false, okay, that's false now. False and true, that's going to be false. False and true, false. False and true, false. And then false and false. That's going to be false. So there is my truth table column. I'm going to put a little asterisk under that because that's the final answer. That's going to be the column I compare with the column from the next one. Are you with me so far? Am I going through this too fast? Okay. All right, so the next one I'm going to do in blue because orange and blue is the best color combination. If you know, you know. All right, so P and Q, okay, I'm going to do the parentheses first. So P and Q. And you just told me I'm not going to make you repeat it. And a statement is true when they're both true. So I'm going to go down the P and the Q column. So true and true is going to be true. True and true is true. True and false is false. True and false is false. And then the rest of them start with a false. So all 4 of the last ones are going to be false because false and anything is automatically going to be false. I'm going to do the same thing for P and R. That's the other set of parentheses. So P and R, I'm going to put a little blue dot because when the columns are separated, that's when I have a hard time. So I just want to make sure I put a little dot over the P and the R. So P and R now. So true and true. True and false. That's going to be false. True and true. Yep. True and false, that's going to be false. And then again, the last 4 all start with a false statement. So a false and whatever is going to be false. So I fill that in. And finally, at long last, I am now going to connect those 2 sets of parentheses with an or. So I've got P and Q or P and R. And I'm going to put a check mark over both those columns. I'm connecting with an or. You've already told me an or is true when either one is true. So let's dive in. So true or true, that first one's true. True or false, the second one is true. False or true, the third one's true. And then if you notice, all the last ones are both false or false. So those are automatically false. So as I'm writing in all the F's, and I put my little asterisk right there, are those columns exactly the same? Yes, that's what it means to be equivalent. Now, if there's any difference, even if there's just 3 T's and one of the T's is down at the bottom, okay, not equivalent. Have to be exact same number of T's and F's in the exact same places. Okay, so these 2 things are equivalent. So that's what it means for 2 statements to be equivalent. So what we're going to do in the rest of this section and the next section is we're just going to apply that new bit of knowledge. So here's the first type of problem you're going to see some of. I'm going to do one, and then on the second page, there's one just like this for you to do. This is example 1. And what you're asked to do, and what we're all asked to do, is select the statement that is not equivalent. Okay, so meaning it doesn't have the same truth value. Select the statement that is not equivalent to Miguel is sick or on vacation. So we're just going to go through the same process we've been doing with every problem we've had with words. First thing I'm going to do is I'm going to declare my 2 simple statements. Okay, so I'm going to have a statement P and a statement Q. Just remember, I've said this before, you know this, we always define our simple statements without any negations. So Miguel is sick. That's the first simple statement. The second simple statement is Miguel is on vacation. All right, so I'm sorry that's bleeding a little bit off the screen. I wasn't thinking ahead where I put my P and my Q. So what I'm going to do, and you can, if you're faster at this than me, you can work ahead. For each of the statements I see, I'm now going to write it symbolically. Okay, that way I can do my truth table in just a minute. So the original statement, I'm just going to write the symbols right above it. It says Miguel is sick or on vacation. So Miguel is sick is P. The or is the disjunction, so the V symbol, and then on vacation is Q. So the original statement is P or Q. Now I'm going to write each of the options because remember, we're looking for which one does not mean the same thing. So some of those mean the same thing as Miguel is sick or on vacation, and some of those mean something different. So the next one is, if Miguel is sick, then he's not on vacation. So it's a conditional statement, so I need an arrow. If he is sick, P, then he is not on vacation, squiggly Q. There we go. Am I causing any confusion in anybody as we're going through this? This is stuff we've done before, so I'm just kind of rolling along. So if I'm holding you up, let me know. Okay. The next one is Miguel is on vacation or sick. So you notice this one just changes the order. We haven't really demonstrated that it's equivalent if the order is different. So we're going to do that in just a minute. So if Miguel is on vacation is Q, or sick is P. So Q or P is what that one is. Statement C is if Miguel is not sick, then he's on vacation. So that's another conditional statement. So there's my arrow. If he is not sick, so that's squiggly P, then he is on vacation. That's Q. And last but not least, if Miguel is not on vacation, then he is sick. So again, another conditional statement. If he is not on vacation, that's squiggly Q, then he is sick. That is P. So there's my statements. And now it's just a matter of doing a truth table to determine which ones are and which ones are not the same thing. So here's my truth table down here. I'm going to slide up just a little bit so everybody can see. So I'm going to put in my T's and my F's. My same 4 options that I have every time. It'll be the same 4 options you have on your problem in just a minute. And now I'm going to do a column for the original statement. So P or Q. That is Miguel is sick or on vacation. That's the original statement we have. So it's an or statement. So an or statement's true when either one is true. So we've got true, 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 and then false for the last one. I'm going to pause. I'm going to let you get caught up because I don't want to get ahead of you on this because I think that this is a relatively simple problem compared to some things we've done before. All right, so my next statement A is if P, then not Q. So what I'm going to do next is I'm going to have a squiggly Q column because I need that negation. And you remember a negation is true when, a negation just changes the value. So Q is true, false, true, false. So the negation is false, true, false, true. So if P, then squiggly Q. Okay, now I'm going to pause because I want you to remind me because this is a last class thing, so it's a little less repeated. So when is the conditional statement false? When it's reverse. Yes, it's true, then false. You met the condition, you got the 90, but then you didn't get the A. The consequence doesn't happen. That's supposed to happen. So T then F is the only false one. All the other ones are true. Okay, T then F. So here we go. P then squiggly Q. So true then false. Right away we have the false one. That is you met the condition. It's true. You did not get the consequence. It's false. So that's why that one's false. Then I have true, then true. You met the condition. You got the appropriate consequence. So that's true. And then false, then false. You didn't meet the condition. So logically, that statement doesn't apply. So it doesn't matter what the consequence is. And then false, then true. Same thing. Since the condition is false, the statement doesn't apply. It doesn't matter what the consequence is. Okay, so I'm going to put a check mark under my original statement right here. TTTF. So first, Is statement A, is if Miguel is sick, then he's not on vacation. Is that the same thing as saying Miguel is sick or on vacation? Are they the same? No. Why not? Why are you shaking your head no? Because why? Because how does this column right here, my original statement, compare with this column right here? Are they exactly the same? No. So this is not equivalent. Okay. So I'm gonna put an X right there. That one's not equivalent. All right, let's do the next one. Statement B, Q or P. Well, the disjunction is true when either one is true. So true or true, the first one's true, the second one's going to be true, the third one's going to be true, the fourth one's false. So now, looking back at the original statement, is this equivalent to the original statement? Yeah, perfect. Okay, it's the same truth value. So I'm going to put a check mark under that one. That's fine. Now, this problem only wanted to know which ones were not equivalent, but we'll identify both. For statement C, it's if squiggly P, then Q, so I need a squiggly P column. So P is TTFF, so squiggly P is going to be just the reverse. So that's going to be FF and then true, true. And now I'm going to do the conditional statement. If squiggly P, then Q. You told me just a minute ago the conditional statement is true at all times except for T, then F. So squiggly P, then Q. So squiggly P is F, then T. That's fine. That's true. Squiggly P is F, then F. That's fine. That's true. Squiggly P is T, true, then true. That's fine. True. And last but not least, squiggly P is true, then false. That one's false. So after you've written that down, make this determination. Is saying, if Miguel is not sick, then he is on vacation, the same thing as saying Miguel is sick or on vacation? Do those have the same meaning? Yes, because the columns are the same. But notice the words are completely different, right? But logically, you are communicating the same thing. If you say Miguel is either sick or on vacation, that is the same thing as saying if Miguel is not sick, then he must be on vacation. Okay, those are the same. Okay, so the last one, squiggly Q, then P. It's another conditional statement. The only time the conditional is false is if you have T, then F. So here is squiggly Q, here's P. So F, then T, that is true. Squiggly Q is T, then T, that's true. Squiggly Q is F, then F, that's true. And finally, squiggly Q is T, then F, that is false. And one more time, we see that that one is equivalent to the original statement as well. So the only one that is not the same is the A statement. Is everyone tracking what makes two statements equivalent? Are you identifying that? So again, you see, as long as you can do the basic truth table facts, you can determine if statements are equivalent. So flip the page. I'm going to give you 2 or 3 minutes to do as much as you can of exercise 2. It's essentially the same thing. If you need anything, raise your hand. I will run to you and help you as best as I possibly can. All right, I'm gonna get started on this. Hopefully you've got a healthy bit of it done. Maybe you're not done because it is a longish problem. So I've defined the simple statement P to be it is raining. I've defined the simple statement Q to be I need a jacket. So what that means is my original statement, if it is raining, then I need a jacket, is if P arrow Q. That's the first statement. So we will do, that will be our first column, P arrow Q down here when we get ready to do our truth tables to see which one is not equivalent to the original statement. Statement A, it is not raining, so that is squiggly P, or I need a jacket, that's statement Q, so you can see that written right here. I need a jacket, Q, or it is not raining, Q or squiggly P. That's the same thing as A. We just saw that in the previous problem, but we'll do the truth table anyway. C is if I need a jacket, so Q, then, so my arrow, it is raining, P, so Q, then P, you see that right here. And finally, if I do not need a jacket, so that's squiggly Q, then my arrow, it is not raining, so squiggly Q, then squiggly P. There are my 5 statements written for me. So here's my original statement, if P then Q. We're kind of hitting that nail on the head today, and we are just talking about that the conditional statement is false when you have T then F. So T then T is going to be true, T then F is going to be false, and then false then true is true, false then false is true. Great. Just because I'm going to need them both, and I don't know when you did it, it doesn't have to be in this order. I'm going to do a column for squiggly P and squiggly Q just to get them out of the way. So squiggly P is going to be F, F, T, T. Again, if you did these a little later, when you needed them, that's fine. And then squiggly Q is F, T, F, T. I'm going to just do one column, if you'll allow me, for A and B, just to save a little time because they're the same thing. They're both a squiggly P or a Q. We've already noted that the order of the disjunction does not matter at all. So I'm just going to do a squiggly P or Q. This is going to accommodate both options A and B. So squiggly P or Q is false or true. That's true. Squiggly P or Q, false or false, that's false. Squiggly P or Q, true or true is true. And squiggly P or Q, true or false is true. So here's my original statement right here with a check mark. A and B, both of those, are they the same as the original statement or are they different? They're both the same. Okay, I'm going to put a check mark. So those ones are not the answer to the question because we are looking for the one that is not the same. Okay, so the next one is Q then P. Okay, Q then P. I'm going to look at my 2 columns backwards. So we're starting with the Q column going in the direction of the P column. So Q then P. The first one is true then true. That is true. The next one, false then true. That is true. The next one, true then false. That's false. And then false then false. That's true. So when I reverse the order, if it is raining, then I need a jacket. I reverse it to if I need a jacket, then it's raining. Is that the same thing? Do those mean the same thing? No, I see a couple no's. I'm hoping everybody agrees and can notice that that column is different. So I'm going to cross out the C. That one is not equivalent. And then last but not least, squiggly Q, then squiggly P. So the squiggly columns, I'm going to start with the squiggly Q column. I'm going to go backwards to the squiggly P column in my order. So false then false is true. True then false, that's false. False then true is true. And then true then true is true. So if I flip the order of both statements and also negate both statements, does that mean the same thing as my original? Yes. Okay, great. So there's only one of those there that is not equivalent. Okay, so that was a lot of busy work. Before I move on, are we okay with that? We feel settled. Basically, that problem there encompasses pretty much everything we've done in all the sections up till now. Okay, we've talked about statements being written symbolically. We've talked about connectives. We've talked about the truth tables. And now in this section, we're talking about equivalent statements. So basically, that is a good summary of where we've been up to here. All right, well, here's something we noticed in this problem. I started with this conditional statement right here. If it is raining, then I need a jacket. And I saw two things related to the conditional statement. I saw that if I just flip the statements backwards, if I need a jacket, then it's raining, that doesn't mean the same thing. I also saw that if I flip the statements backwards and also negate them both, if I do not need a jacket, then it's not raining. I did get the same thing. Now, is that supposed to happen? Well, that's a great question. So here we're going to look at the conditional statement and we're going to look at the equivalences. So first, there are four statements related to my conditional statement. So what I've done here is I said, okay, I tried to create two statements that are as short as possible so that we don't have to do a whole lot of writing. So statement P is it rains, and statement Q is I get wet. Okay, I don't know that I can think of anything shorter than those two things. Okay, so what we're going to do is we're just going to write in words the four statements related to the conditional. So the first one is the conditional statement itself, P then Q. So what is P then Q? Just say it in words, then we'll write it. P then Q is what? If it rains, then I get wet. All right, let's write that down. If it rains, then I get wet. Fantastic. Now, you may have used these words in common lingo before. Maybe you do know what they mean. Maybe you don't. The next statement that's related to the conditional statement is called the converse. Now, notice what the converse does. The converse takes my original statement, P then Q, and all it does is it changes the order of the two statements. Do you see what I'm talking about there? So if I reverse the order of the two statements, if Q then P, what is that in words? Perfect. If I get wet, then it rains. Lovely. That's called the converse, when you flip the order and you do nothing more. The next statement is called the inverse. Now notice what the inverse does. Tell me, how does the inverse compare to the original conditional statement? What did we do? You negate both. Did I change the order? Nope, just negating. Okay, so the inverse is if what? If it does not rain, what'd you say? Then I don't get wet. Lovely. Excellent work. Order is the same as the original statement, negated them. Now the last one, this is the word that's most fun to say and to spell. It's called the contrapositive. And notice on the contrapositive, we do both things. Notice the original statement was P then Q. So notice I flipped the order, QP, but I also negated both. We did both things. So what this says is if I do not get wet, then it didn't rain or doesn't rain. So all we did right there is we identified the four statements, what they're called, the conditional statement, then the converse, which is split the order, the inverse, which is negate, and then the contrapositive, which is do both those things. So here's what you're going to do. I'm going to give you like 90 seconds to do as much of it as you can. What I want you to do is the truth table, and I want to know which ones are equivalent to the original statement. So the truth table, I got a blank truth table right here at the top of the page, exercise 3. So go ahead and do as much truth table as you can in 90 seconds to determine which ones are equivalent. And as you're structuring your truth table, I'm going to just do a squiggly P and a squiggly Q column while you're working just to get started. All right, so we've done a bunch of conditional truth tables, so I'm just going to go ahead and get started. Notice I've started my truth table. I've done the squiggly P, I've done the squiggly Q, and now I've got my original conditional statement in this column, and then I've labeled the converse, then the inverse, and the contrapositive in the subsequent columns. So the conditional statement is true under all circumstances except true then false. That's the false one. So here we go. P then Q. True then true. That's going to be true. True then false, that's false. False then true, that's true. False then false, that's true. So there's my original statement. I'm going to put a check mark under it because that's the one I want to compare the others to. When I flip them around, we kind of saw this in the previous exercise that you did. When I flip them around, now I'm going from Q to P. So Q to P, true then true is true. False then true is true. True then false is false. And then, true then false is false, and then false is true. And so we see that the converse is not the same thing. They are not logically equivalent. You are not communicating the same thing when you reverse the order of the two statements. The inverse, squiggly P, then squiggly Q. Okay, squiggly P, then squiggly Q. So I've got false, then false. That's true. False, then true is true. True then false is false, and then true then true is true. So once again, when I'm comparing to my original statement, is the inverse equivalent? Nope. And then last but not least, the contrapositive. I flip the order, I negate both. So squiggly Q then squiggly P. So I've got false then false, it's true. True then false, that's false. False then true, it's true. And finally, true then true, that's true. So the contrapositive, is that the same thing as the original statement? Yes. Okay. So what we see here is the original statement is equivalent to the contrapositive. What we can also note from the truth table is that the converse and the inverse are equivalent. And here's the reason why. Those two statements are contrapositives of each other. Notice this one's Q then P, and what's the contrapositive? The contrapositive means flip the order and negate. So the inverse is the order's flipped and negated. So those two are actually contrapositives of each other as well. That's lesser knowledge. You don't need to know that. All I need you to know is that when you have a conditional statement, when you flip the order and negate both statements, you've got what's called the contrapositive, and it's equivalent to your original statement. So here's how we're going to finish this section. We've got 4 problems that are essentially the same thing. I'm going to do the first one. I'm going to give you a couple minutes on each of the other ones. What we're going to do is we're going to take each conditional statement and we're going to rewrite the conditional statement as its equivalent contrapositive. You can do as much abbreviating as you want because I know there's a little bit of legwork here, but here's my first problem. If the quadrilateral is a parallelogram, then opposite sides are parallel. Okay, here we go. We're ready to rumble. I'm just going to real quick, I'm going to abbreviate and I'm going to outline what my simple statements are. So statement P, I'm going to define as the quad. I'm going to abbreviate quad is a parallelogram. And Q is opposite sides. I'm going to just go op sides parallel. Just kind of saving a couple words here and there to make things a little more manageable. Okay, so here goes. If the quadrilateral is a parallelogram, so that's P, then there's my arrow, opposite sides are parallel. That's Q. That's my statement. So now what I'm going to do is symbolically, I'm going to form the contrapositive. The contrapositive means what? What 2 things I'm going to do? Tell me one thing. I'm going to negate both of them, and then I'm also going to flip the order. Yes. So it's going to be squiggly Q, then squiggly P. And the reason I'm having you write all this out is you're going to notice in your last 2 exercises, some of the original part is going to already be negated. So we're going to have to figure out and navigate, what do I do then? Okay, so that's why I'm having you go step by step here. So now I'm just going to write that in words. So here we go. If squiggly Q, opposite sides are not parallel, then squiggly P. The quadrilateral is not a parallelogram. I tried to make the statements in the other examples a little bit shorter. But that's the process. It's the same process we're going to do in some problems in the next section, and we'll get to as much of that as we can. And if we don't get to the whole thing today, that's fine. So, all right, exercise 4. It's going to be pretty much the same thing. That way, you get to write. Writing helps you remember. So, give it a go. All right, so check your work with my work. Ask questions where we differ. Remember, if you made a mistake, it's not the end of the world. Mistakes mean you're learning. So here we go. The statement is, if you live in Los Angeles, then you live in California. So I'm going to make statement P, you live in LA. And then statement Q is, you live in California. I'm going to abbreviate CA. So the original statement, again, this one's just like the previous one. That way you have the ability to write it down, and writing leads to remembering. So if you live in Los Angeles, P, then you live in California, Q. If P, then Q. Same thing as last time, we're going to form the contrapositive. The key learning here today is that the contrapositive means negating and flipping the order. So that's going to be squiggly Q, then squiggly P. And now I'm going to rewrite what I have. So squiggly Q, if you don't live in LA, or excuse me, if you don't live in California, then squiggly P, you don't live in LA. Those two things are logically equivalent. If you got a question, ask it. If not, exercise 5, second to last problem from this section right here. Same thing. Now we're going to have to just navigate the situation where one of the statements in the original is already negated. What does that mean for the contrapositive? So give it your best go. See how we do. All right, so statement P, I have defined to be you have clean clothes. Statement Q is it is time to do the laundry. Key point, just in case you forgot, we always define simple statements in the positive, no negations. So that means if you do not have clean clothes, then it is time to do the laundry. So if you do not have clean clothes, that is squiggly P. Then it is time to do the laundry. That's Q. Up till now, that is complete review. Hopefully you did not struggle to do that. Now this is the new bit of information. We need to form the contrapositive. Contrapositive means flip the order and negate both. So that means what's going to be the statement over here on the left of my arrow? Squiggly Q. Well, I wrote P, but I said Q. Now I've made a disastrous mess. Let me try again. Squiggly Q. Then what's going to be the thing on the right of the arrow? Plain old P. When you negate a negate, two negatives make a positive. Okay, just like arithmetic. So there we go. Squiggly Q, then P. If you didn't get that on this one, don't worry. The next problem is going to be super similar. It's going to give you a chance to sort it through, but let's write this out. So squiggly Q is, it is not time to do the laundry. So if it is not time to do laundry, then P, you have clean clothes. There we go. All right, one more. Last problem for this section. It's the same thing. Form the contrapositive, and let's see what the equivalent statement is to if you are watching Shamu, then you are not at Disney World. All right, so on this problem right here, statement P is going to be you are watching Shamu. So then statement Q is going to be you are at Disney. I'm just going to abbreviate DW for that. So if you are watching Shamu, P, then you are not at Disney, squiggly Q. So what's the contrapositive of that then? What do I get? Q, then squiggly P. You change the order and you negate both. All right, so now I'll write that in words and we'll be done. So Q is if you are at Disney World. Then squiggly P, you are not watching Shamu.